Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 8 of grade 8 Algebraic expressions and identities. Algebraic expressions are a combination of variables and constants connected with one or more mathematical operators. Let's take 4x plus 7 here. 4 is the coefficient, x is the variable, plus is the operator, and 7 is the constant. So we are writing all these things in on basis of the variable that we are available with. What is a variable? An entity which varies or changes its value and is not consistent, that is called a variable. The variable doesn't take any fixed value. What is a constant? An entity which remains fixed and unchanged throughout. When the variable can take different values, the constant is always fixed. Okay, so the constant cannot take any fixed value. It will be always same throughout. Terms. The elements in an algebraic expression separated by operators are called terms. There are two types of terms, like terms and unlike terms. Terms means it will contain a coefficient, a variable along with its degree. It can be even in the powered form. Now let's come to the like terms and unlike terms. When the variables of different terms are identical, they are like terms, like 2x, 5x, 5x square, 12x square. Here 2x and 5x are like terms, 5x square, 12x square are like terms. When the variables of different terms are not identical, they are called unlike terms. 2x and 5x square. Here the degree of or the power of the variable is different. Even if the coefficients are different, we have to get it like the variable must be in equal power. Then only they are like, otherwise they are unlike. In the terms 5x square y and 12x square, the x square term is same with same power, but we are having one more variable which is y, which is not found in the second term. What are the factors? In 3xy, factors are 3x and y, like we have the factors of 6 as 2 and 3 or 1 and 6, like that. Types of algebraic expressions. We have some types of algebraic expressions, and the first one is when only one term you call it like monomial. 4x square is an example. When we have two terms, it is binomial, 2x plus 5. When we have three terms, it is trinomial. Then 3x square plus 4xy plus 7 is an example. And altogether you can call it like polynomial. An algebraic expression with one or more terms in it with every variable having non-negative integers or positive integers or whole numbers on power. So the power on the variable should be non-negative integers or positive integers or whole numbers. It cannot have any fraction or decimal on the power. Now let's see how we can add and subtract these polynomials. While adding or subtracting polynomials, identify the like terms and add or subtract them. First thing you have to do is find the like terms. Okay, so 2x plus 3x plus 5x means all the powers are 1 and only one variable. Hence, you can say it like the answer is 10x. They are like terms. For unlike terms, 2x plus 6y plus 7x minus 11y, group the like terms together, then do the operation. 2x plus 7x plus 6y minus 11y, which is equal to 9x minus 5y. Now subtract 4x square y plus 3x minus 5y from 7x square y minus 4x plus 2y. You should note the sentence. You have to subtract the first from the other. So you have to write the second one first. 7x square y minus 4x plus 2y minus 4x square y plus 3x minus 5y. So the answer you are getting is 7x square y minus 4x square y minus 4x minus 3x plus 2y plus 5y. Here we have grouped the like term, which is equal to 3x square y minus 7x plus 7y. Y algebraic expressions. Example, to calculate the perimeter of a square, you can use the algebraic expressions like the perimeters equation. Let's take a square of side 4 centimeter or 4 units. Then its perimeter is 16. 4 plus 4 plus 4 plus 4. Instead of adding 4 times, you just want to multiply it with a variable. That is 4 into x. That is 4 into 4. That is equal to 16. In area calculations also, we can use the variables in algebraic expressions like x square. It is enough. Let's take the next one. multiplying 3 or more polynomials. We are dealing with the multiplications of polynomials. So the first one is multiplying 3 or more monomials. In order to multiply the monomials, you have to multiply the first two monomials which are available in the 3. Then multiply the resultant with the third monomial. For example, 4xy into 5x square y square into 6x cube y cube, you have to do the first two 4xy into 5x square y square at the beginning. Or else you can just calculate the complete coefficient multiplied together and the variables separately regrouped and multiplied together. So the answer is 120 into x raised to 1 plus 2 plus 3 into y raised to 1 plus 2 plus 3. Answer is 120 into x raised to 6 into y raised to 6. The answer is 120 x raised to 6 y raised to 6. Now let's deal with how to multiply the polynomial by another polynomial. Multiply every term in first polynomial by every term in second polynomial. 3x plus 4y into 2x plus 3y means you have to distribute it. 3x have to be taken to the all terms of the next polynomial, that is 2x plus 3y into 3x. Likewise 4y also have to be taken to all terms of the next polynomial. Then 3x into 2x plus 3x into 3y plus 4y into 2x plus 4y into 3y. Answer is 6x square plus 9xy plus 8xy plus 12y square, that is 6x square plus 17xy plus 12y square. Now let's do how to multiply polynomial by a polynomial. Let's split the cases like multiplication of binomial and trinomial, monomial, let's split like that. In the binomial trinomial multiplication, you have to take that binomial towards the each term of trinomial. So the answer is 6x square plus that completely. Monomial into monomial, and this you can apply the laws of exponents like x raised to a into x raised to b equal to x raised to a plus b. By applying the distributive law also, as we have done before, we can multiply monomial into monomial, monomial into binomial, monomial into trinomial, binomial into binomial, binomial into trinomial. All these are possible with these kind of law applications. Let's take the last one, binomial into trinomial. 3x square plus 4y into 7x square plus y plus 3xy. Here also we are doing it with the distribution. We are distributing 3x square and 4y with each term in the trinomial. The last one, find the area of the below rooms 1, 2, 3. Here we are applying what we have studied so far. We are applying it for the room 1, room 2 and room 3. The areas are calculated after calculating the area of each one and adding them. Length into breadth is used for calculating the area, then they are added. What are the identities? An identity is an equation which is true for all values of the variables in the equation. All identities are equal equations, but all equations may not be identities. Let's see what are the standard identities. A plus b the whole square is equal to a square plus 2ab plus b square. A minus b the whole square is equal to a square minus 2ab plus b square. A minus b into a plus b is equal to a square minus b square. And it have a general form like x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. And this proof is also given along with it. You can check it. In order to find the 4x plus 5y the whole square, you can use the standard identity. And you just want to subtract or substitute a with the 4x and b with the 5y, and you can completely give it as the substitution. Now to calculate the distance covered by a car in x minus 2 hours, if it travels at the speed of 2x square plus 6x minus 20 km per hour, you just want to give it to the speed equation, that is distance by time, because distance and time are given and you can substitute it. Speed and time are given, so you can substitute it with the given or obtained values, and you can proceed through the multiplications. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please be stay tuned for the upcoming parts of your classes.